In the time of René Descartes, function was defined as everything one could draw on a piece of paper. With the development of algebra, this definition has become obsolete. Function was then defined in a new manner, and that definition holds to this day. Definition: a rule f which maps a set A in a set B, notation f maps A to B, which takes every element of set A and connects it with exactly one element of set B, notation for every x of A, there exists exactly one element y from set B, such that statement f of x is equal to y holds truth, is called a function. A need for this definition has arose because of a wish that function for each value that it takes gives as its result exactly one value which is by that rule connected with it. Let's now turn to our problem for the beginning. How much is a square root of 4? A function's square root is defined in a set of positive real numbers which includes 0. That basically means that function's square root maps a set of R0 plus to set R0 plus. A function of square root is defined in the following manner. For an arbitrary number x which function square root takes from its domain, it connects exactly one element y from its codomain, such that statement y squared is equal to x holds true. In our case, we see that x is equal to 4, and we see that y is equal to 2, and that is because 2 squared is equal 4, and 2 and 4 are positive real numbers. Now this is what a graph of a square root function looks like. This is an x-axis and this is a y-axis. This is origin 0. A square root function has this graph. Basically y is equal to a square root of x. So the only correct computation of a square root of 4 is one which gives a solution of 2. Now I would like to show why a square root of 4 is not equal to negative 2. In the beginning of this video, we made a claim that there was a need for a function that for every value given, a function had to return exactly one unique value as its result. If statement square root of x is equal to negative 2 was correct, we would have two values, 2 and negative 2, as the result of the function for a value 4, which is a contradiction with our definition that for every x from a set of positive real numbers, there exists exactly one y from the set of real positive numbers, which includes 0, such that y is equal to a square root of x. Now I want to show on an example what application of square root function looks like when solving a quadratic equation. In order to explain this concept, I will take a simple example. So this is our example. Solve an equation x squared is equal to 4. Now most people, when they see an equation x squared is equal to 4, will immediately jump to apply square root function on both sides. And then they will cancel out a square root function with a square, and then they will make a claim that x is equal to a square root of 4. Now they claim that square root of 4 is equal to plus or minus 2, and then they get the solution to be x is equal to plus or minus 2. And this solution is completely wrong. In this step right here, a square root and a square cannot be cancelled out. And in this step right here, a square root of 4 is not equal to a plus or minus 2. So the function f of x, which is equal to x squared, has the following graph. X-axis and y-axis, and 0 is our origin. So 1, 1, negative 1. For 2, we have 2, 3, 4. And we have negative 2 on this side. So our parabola looks like this. This is a function y is equal to x squared. From this graph, we clearly see that equation x squared is equal to 4 has two solutions, and that those solutions are x is equal to 2 or x is equal to negative 2. Therefore, in the previous case, where I have demonstrated the wrong way to solve this equation, the solutions which were obtained were correct solutions. Method which was used to solve the equation was filled with mistakes. That means that whoever uses this method to solve an equation had more luck than brains. Problem lies in the fact that a function f of x is equal to x squared doesn't have an inverse function on its entire domain. Let's take a look at the graph of a function f of x is equal to x squared. F of x is equal to x squared. This is x-axis and this is y-axis, and we have the origin 0. Now we see that this graph doesn't pass the horizontal line test. If we put a horizontal line like this, it has an intersection with the graph of a function which has more than a one dot in it. This shows that a function is not one-to-one. Basically, f is not a one-to-one function. So, for example, we have that 2 squared is equal to 4, and we also have that negative 2 squared is equal to 4. Now, the question is whether we should take the value of a square root to be equal to 2, or we should take that value of a square root of 4 is negative 2. When this problem first appeared, it was decided that as a value of a square root function, we should take positive values. This number we call a principal square root. Now a function y is equal to x squared has an inverse function which is defined on only the part of its domain. Now let's draw graphs of function f of x is equal to x squared and the square root of x in the same coordinate system. Basically what we get is this. We get the parabola of the f of x is x squared function, and we have this branch of a square root function. We see that a function's square root is defined only on the part of positive real numbers, which includes 0, and that function f of x is equal to x squared is defined on the entire set of real numbers. Now, solving an equation that x to the power 2 is equal to 4, with everything previous said in mind, will look like this. For every x, which is a real number, we know that x squared is larger or equal to 0. We know that 4 is larger or equal to 0. So we see that both values, x squared and 4, belong in a domain of a square root function. That means that we can take a square root to both sides of the equation. So we get that the square root of x squared is equal to a square root of 4. Now, because x is a real number, we have to take two cases into account. The first case is for x larger or equal to 0. We have that x squared is also larger or equal to 0. And then we have that the square root of x squared is equal to x. Now a second case is for the number x, which is smaller than 0. We then have that x squared is larger or equal to 0, and we have that negative x is larger than 0. Therefore, we get that square root of x squared is equal to negative x. Combining both of these cases, we get that square root of x squared is equal to an absolute value of x. So from the step that square root of x squared is equal to a square root of 4, we get that absolute value of x is equal to a square root of 4. We have already seen that square root of 4 is equal to 2, and now combining these two statements, we get that absolute value of x is equal to 2. Now, a function absolute value, which maps r to r positive including 0, is a function of absolute value, and it is defined in the following manner. Absolute value of x is equal to x if x is larger or equal to 0, and negative x is if x is smaller than 0. We previously got that absolute value of x is equal to 2. Now our first case is for x larger or equal to 0. In this case, we know that absolute value of x is equal to x, and because absolute value of x is equal to 2, we get that x is equal to 2. In the second case, which is for x smaller than 0, we know that absolute value of x is equal to negative x. In this case, from absolute value of x is equal to 2, we get that negative x is equal to 2, and that means that x is equal to negative 2. This is where we get that an equation x squared is equal to 4 has two solutions, and those solutions are x1 is equal to 2, and the second solution is x2, which is equal to negative 2. Based on our previous work, we clearly see a mistake in the part where I have demonstrated method which students most often use to solve a problem x squared is equal to 4. We see that a mistake lies in the fact that in that method, a sign of a minus originated from a square root function with which in reality it has nothing to do. If you use the correct method to solve an equation x squared is equal to 4, it is clearly visible that a sign of minus originates from an absolute value function. Now it is not hard to see that a square root function is used as a tool to solve a problem x squared is equal to 4. Solving an equation x squared is equal to 4 and calculating a square root of 4 are two problems which are completely different. It is always true that a square root of 4 is equal to 2, and by solving an equation x squared is equal to 4, we get the solutions of this equation to be x is equal to 2 or x is equal to negative 2. If you have watched this video so far, I suspect that you have found it to be somewhat useful. I'm looking forward to reading your comments and suggestions. Please subscribe to the channel if you want to see more problems like this getting solved. I suggest that you watch my next video, which I have linked here.